So hello everybody. Today's technical webinar is dedicated to PVT heat pump, Joulson's new product range designed to meet electricity, domestic hot water, and above all heating needs. The plan for the webinar is the following. First, I'll give you a quick reminder of how a heat pump works to make sure we're speaking the same language and that the elements I'm going to use are clear. Then I'll introduce you to the new Spring 4 panel with its new features and characteristics and the extent to which it has been designed to be specifically adapted and dedicated to this type of coupling. Next, I'll outline the advantages and performance of the Spring 4 panel compared with other heating solutions on the market, and mainly the one with PV plus air-to-water heat pump. And finally, we'll focus on the technical side with the kits and so on that revolve around the panels and are enable them to be linked together and then to the heat pump and how this installation is set up. So first of all, let's look at how a heat pump works. As a reminder, a heat pump is the transformation of a refrigerant fluid into several states, enabling energy to be transferred from a first medium A to a second medium B by following a thermodynamic cycle that enables the refrigerant fluid to be transformed by means of, firstly, a compressor which supplies most of the energy, increasing pressure and temperature to meet production needs. At the outlet of this compressor, we obtain high pressure steam at a higher temperature. This high pressure steam then passes through the condenser where it is exchanged and used to meet heating and domestic hot water requirements. This is known as the production circuit. After passing through the condenser, the fluid drops in temperature. It then expands inside an expansion valve to become a low pressure, low temperature liquid. And finally, this liquid is converted to low pressure steam by means of an evaporator, increasing its temperature while remaining at low pressure. It is on this side that the closed Glicol circuit that runs through the Spring 4 hybrid panels will supply energy, acting as the sole cold source. This is what is known as the collection circuits. In other words, the heat from an external source will be recovered and fed into the thermodynamic cycle to continuously power the heat pump. We therefore have three separated closed circuits. The first upstream Glicol circuit, which is the cold source that will exchange heat on the evaporator side of the heat pump. Then the second closed circuit, when is the refrigerant's thermodynamic cycle. And finally, a third and last distinct cycle that exchanges on the condenser side, the production circuits that will meet demands. Then there are the various terms used in the heat pump world. So we're going to see them. First, we have COP or COP for coefficient of performance. The COP is defined as the number of kilowatt of heat I obtain from my production circuits divided by the number of kilowatt of electricity required for the thermodynamic cycle, compression, consumption, circulator, and etc. This COP is shown on the data sheets for the heat pumps at a specific operating point, and very often B0W35, which means that the water temperature at the collector inlet is 0 degrees and the heating water production temperature is 35 degrees. We also talk about the scope. Here we had the term seasonal. The difference here will be the temperature of the Glicol water entering the system, which will be variable as auto temperatures vary according to the season. And finally, we're going to talk about the third and last term that will be of particular interest to us, the SPF, seasonal performance factor, which will give an idea of the performance, not just of the heat pump, but of the system as a whole. In other words, the real efficiency of a system from a dynamic simulation or monitoring. So it's really the conception of the wall circulators. We could also compare the COP to the power in watt peak of a panel and the SPF, which will be more the total average power of the panel or the installation, or maybe the predictable power, taking into account the transformation of the current of the whole system. So much for this brief reminders. I'd now like to move on to the Spring Fork Ring hybrid panel and show you the specific features that led to the design of the product and the essential improvements that have been developed. First of all, our new Spring Fork panel is an ultra-strong aluminum heat exchanger specifically designed for solar energy and aluminum that can also be recycled ad infinitum. This was an essential element. It has to have a product in a material that is robust and that can react well to use that is not always according to the rules. Secondly, TOPCon technology on the front panel is as the cutting edge of photovoltaic technology with a yield of almost 22%. And finally, it's a panel made in France, assembled in our ISO 9001 certified factory in the Ain region of France. On this subject, the transparency that is dear to us at Dualsun, the flash photovoltaic panels is 100% Asian. The aluminum heat exchanger is 100% made from European products and assembled in Europe. And on the other hand, it is the assembly of the photovoltaic and the thermal parts that is done in France and that constitutes a significant added value to the product that allow the custom affixations. And this is where the made in France label comes from. The version used for this combination will be the Spring Fork portrait field. There is also an insulated version dedicated to domestic hot water application for production purpose only. Here, the purpose of the fins you can see here is to capture the energy from the air at night, because since we're trying to meet constant heating needs, both at night and during the day, we also need to be able to provide calories at night and during the day. This panel has been designed to be the sole source of heat for the heat pump. These fins provide 20% more thermal power than the classic version, the non-insulated version without the fins, and also triple the surface area of the equivalent heat exchanger, which uses three sources of energy: the sun and the roof during the day, and the air at night. We now see the thermal characteristics of the panel. We can talk about the maximum operating pressure, which is 6 bars, a very important factors and much higher than that of the previous version, the Spring 3. This high pressure maintains the constant pressure required for the heat pump to operate. Another important factor is the stagnation temperature, which is 70 degrees, which is the maximum temperature that can be reached when there is no longer any need for heating or domestic hot water, and when it's very hot during the day and the water remains stagnant inside the aluminum profiles. This eliminates any risk of polymerization, or we can also say caramelization or vaporization of the water and glycol, and avoids the need for a self-draining system that would allow the heat to be evacuated to avoid damaging the heat exchanger. Then, among its main advantages, it is firstly a panel that is easy to install, compatible with almost all the installation systems on the market. It is also compatible with the heating engineer standard tools, an important element for robustness and to be able to cope with any errors in handling or compliance with operating speeds. But in any case, and it's also important to have a panel that can withstand high pressure of up to 6 bars. Like I said it before, well beyond the requirements of a heat pump, which also means that pressure losses have been drastically reduced to 20 times less than in our previous version of Spring 3 with its propylene exchanger. This low pressure drops also uh, make for much easier purging and commissioning. Here there is a small graph showing the evolution of pressure losses as a function of flow rates per pound, the curve being that of the Spring 3, the previous version, and the green curve that of the Spring 4, the current version. We can see that the pressure losses are very low, even at high flow. Then here we can see on these pictures the cross section. The heat exchanger is made of aluminum sections like this called MPEs or multiple extrusions, which is the same of the process, which is the name, sorry, of the process used to produce these sections, and also for linguistic reasons, the name given to the sections produced by this process. The glycol water is collected at the bottom and it heats up as it travels through the MPEs here before emerging at the top, at the collector at the top. And in the two collectors that are in an integral part of the panel into which the aluminum profiles are soldered. You can see it here. So, and for this part on the characteristic of the Spring 4 hybrid panel, we'll now look here at the main technical arguments for this offer and how it is positioned on the market. Today, there are a number of solutions for meeting the heating and the domestic hot water needs of household in Europe, including various types of boiler, formerly oil-fired and gas-fired, which are still used today, and more recently wood-fired boiler, pellets, granules, etc. Renewable energies have also been developed. And the most common of which has made quite a significant breakthrough, especially in France, for example, and even in other countries in Europe, with the heat pump as its main market. This is the air-to-water heat pump. This uses another unit to capture the heat from the outside air, which acts as a cold source and transfers the heat to refrigerant, which then supplies the water socket for heating and domestic hot water. The offer we're proposing is based on the same principle, with the difference that the cold source on the collection side will be the glycol water charged with calories as it passes through the panels. This is the heat pump, the PVT heat pump offer. The main advantage is that it eliminates the need for another circuit, which is a very important argument given that the auto units, because this auto unit takes time to set up first. Then you need refrigerant authorization to commission. And above all, it's a visual nuisance. It's often quite difficult to find the right place for it, or maybe some people try to hide it. And finally, it will obviously detract from the facade. And lastly, there is also noise pollution, which is also a problem with this offer because it's a sort of large fan coil unit that turns more or less according to need, and so generates some significant pollution. So all these nuisance disappear with this PVT heat pump, since the only cold source is the roof panel. The only downside is that the hydraulic pipes have to be routed through the attic to get back to the technical room where they can be connected to the heat pump. This can be seen here and on this educational diagram here with the roof installation connected to the heat pump by means of this pipe. Terminal design, which make up the upstream collection circuit on the cold source side, which exchanges heat with the heat pump evaporator. On the production side here, the heat pump can then supply either cast iron radiators at 45 or 55 degrees, or heating panels also at 35 degrees, followed by domestic hot water with intermediate buffer tanks. And of course, there is always an option, the option of producing electricity for the various items of equipment in the house, including the heat pump for self-consumption. Then here you can see the schematic diagram, which is as follows. So you have the two main elements, the hybrid panel spring for on the roof panels connected to the heat pump. Inter-panel links to hydraulically connect the panel together, and inlet-outlet kit to connect hydraulic lines and create a closed circuit. Between these two elements, we set up PVT heat pump station composed of an important element, which is here in 6, the thermostatic valve, which protects the heat pump because we have a minimum and a maximum evaporator inlet temperatures within which we have to stay to avoid sending glycol at a too high temperature. The valve, which therefore allows you as to mitigate with cold here, cold glycol water to limit this temperature. Then we also have a drain valve here to drain the water. For commissioning, we have a filling kit here in 9, 10, and 11 with the generator as well. It has in the inlet outlet kits. I'll come to that just after. There is a plug fitted with a bleeder to be placed at the outlet on the panel, the top end of the panel. We also have here in 11, here in 11, safety valve connected to an expansion, a solar expansion vessel to limit excessively high pressures. And finally, a filter valve here in 12, which prevents the insertion of impurities inside the heat pump. We're now going to see how all this works, as I told you just before. The idea is to be able to meet needs throughout the day and in the cooler winter season, especially heating needs, which are the most important. On the one hand, we have the daytime configuration where the heat from the sun is captured by the PV panel, which will be recovered, as I was saying, by a convective exchange via the heat exchanger at the rear, so as to increase the temperature of the brine. For example, here, I start at 20 degrees and recover heat from inside the panels. It's 15 degrees outside, and I leave at 30 degrees, except that I was saying we have a mixing valve to protect the heat pump evaporator, which I've set manually at 25 degrees so that I can mix it efficiently to leave at maximum 25 degrees, which is here the maximum evaporator inlet temperature. Secondly, at night, this time it's the same mechanism, but this time we recover the heat from the area using the fins on the back that will be captured. For example, if I have a solar return here at -9 degrees in brine with an outside temperature of -1 degree, this will allow me to supply a quantity of energy and go up to -6 degrees. As we can see it here, and then re-enter the heat pump. It's important to remember that the heat pump can continue to operate as long as the solar flow temperature is not lower than the minimum evaporator temperature. This temperature varies between -10 and -25 degrees, depending on the type of heat pump, and so on. And get this in mind that this is a very important factor to be considered depending on the minimum temperatures in the project in question. It's important to understand that the heat pump regulates itself to ensure that the temperature at the evaporator coil inlet is low enough to be able to recover heat from glycol water at -6 degrees for this example. And it does this all the time as long as it's not too cold outside. You should also bear in mind, of course, that the set point downstream on the production circuit side is fixed. And so the heat pump has to do what it needs to do to meet the requirements. The idea is to say that the more I put pressure on my heat pump during the transformation, it is if I come in at -5 degrees and have to go out at 30 degrees, my compressor will have to work harder. So I'll need a lot more kilowatt of electricity, which will inevitably reduce my COP, my COP. To get a clear idea, we need to look at the SPF and look at the real efficiency and of installation over the year, as we'll see next. Before that, we talk about sizing in this following order. First, we determine the heat loss of the house at the temperature considered to be the lowest in the town in question. Then, thanks to this, we determine the most appropriate heat pump to meet those needs. And finally, depending on the heat pump chosen, we obtain the sizing rule, which varies between 1 and 1.5 panels per kilowatt of heat pump. And this depends on two criteria. First, the heat pump technology, on, off, or inventor. And secondly, the minimum temperature at the evaporator inlet, which depends on the temperature considered to be the lowest in the town. Here, for example, with a 9 kilowatt heat pump, I will need between 10 and 12 panels, depending on this criteria and the project area. Okay, you can see different heat pumps with different brands of heat pumps, which may be those that are distributed in your country or not, but this is a natural presentation. If you have a project, you can contact us to make sure we can give you the whole and the main information to accompany you on your project. A case study was carried out by a German research institute, which carried out a dynamic simulation over a full year in order to obtain truly tangible figures for the performance of the system. The assumptions made are the following. We have a family of 4 based in Strasbourg. This is an intermediate household. Based in Strasbourg with a 5.1 Joulson Spring hybrid installation, 12 panel of 425 watt peak, and the determination of the heat loss gave us and made us choose this heat pump, the Getrich GS-HP 12 mAh plus 9 branch water heat pump. Floor area is 140 square meters. Here you can see the domestic hot water heating and electricity consumptions. And that's all. Yeah, we have 12 panels, so which a ratio of 1.17 between 1 and 1.5, like I showed you before. We then compared the dynamic simulation on the basis of these assumptions with the various complete heating solutions on the market. First, fossil-fired boiler, you can see here. Then air-to-water heat pump with an SPF of 3.1. Then PV plus air-to-water heat pump, SPF 3.5. GSH HP geothermal installation, ground-sourced heat pump with an SPF of 4.1, even though this is not necessarily the type of installation with which we're trying to compare ourselves, because the costs are different, the constraints are greater in terms of land, and the installation is more complex, which is also not very widespread. So finally, the PVT heat pump offer comes out on top with an SPF of 4.2 and is the most efficient solution on the market, performing 20% better than the PV plus air-to-water heat pump one. To go a little more detail, this graph here shows changes in outdoor temperatures in Strasbourg over the last 30 years and in 2022. This graph is followed by this one, which shows changes in temperature at the output of the Spring4 hybrid panels as a function of the days of the year. We can see that for almost 4 months, the temperature is negative and will be close to -15 several times in December and January, so that in certain very cold circumstances, the heat pump is forced to be supplemented by the electric backup to meet the household's needs. But this is only 5 times out of the 365 days of the years. In other words, for the rest of the year, the cold source Spring4 panels responded, making it a virtually autonomous system that can meet the household's needs. It's important to bear this in mind. The system is practically self-sufficient and additional electricity is only required very rarely. We end with a final section on the more technical presentation and roof installation, in which we're going to see the different kits that we developed to connect panels between them. First, we have inter-panel connection kits, which will let you connect the panels together. Each kit is made up of 2 cylindrical stainless steel parts with bearing surfaces onto which O-rings and grease are placed to facilitate insertion into the manifold. Assembly is as follows: position the first panel, then insert before positioning the inter-panel links upstream into the collectors of the next panel, then slide the panel along the rail, inserting the kits into the collector of the panel already in place. There are 2 stops to prevent the cylinder from fitting completely into one of the manifolds, but the 2 stops are not compulsory in contact with the manifold surface all the time. Their stroke has been designed to fit all the calipers on the market, which is between 13 and 30 millimeters. Then we have inlet outlet kit, connection kit, which means that once the wall thermal line is connected, we can insert opposing plugs at the 4 pre-ends, including the one with the integrated drain as high up as possible at the highest point of the installation, and elbow fittings of the other 2 and at the other 2 ends to connect the hydraulic lines. Finally, 4 blocking devices are inserted into the plastic of the manifold to hold and prevent the plugs and elbow fittings from moving in relation to the manifolds under the effect of pressure. Finally, here you can see, you can put here grease on the O-rings and then inserting those ones, and also the elbow fittings here and the final connections here to close the circuits. And so finally, we recommend using copper for the hydraulic pipes or range stainless steel with the diameter of the pipe recommended here, depending on the number of PVTs on which the flow rate depends. So first, copper nominal diameter 28, sorry, when you have between 11 and 20 PVT. And range stainless steel, if you use range stainless steel, it's nominal diameter, which is inside diameter, 25 between 9 and 1450, and nominal diameter 32 beyond that. Here you have an FAQs. I don't speak about it, but you can click on it to have main information, a lot of information on different topics, and you have to search by keywords. Also, this slide, and finally, there are a few things to bear in mind when sizing and installing your systems. First is that we impose a maximum of 7 panels per thermal loop. If more, at least you need to do 2 thermal lines and install these 2 thermal lines, ensuring hydraulic balancing, either by means of a T-command loop, if 2 lines are equal, or 3 or more lines are equal, or by installing balancing balls. I'll show you just after. There is no filling direction. You need to respect Z, which means if I enter at the bottom right, I exit at the top left, and vice versa. Then a solar expansion vessel is mandatory. Check if already present in the heat pump. It's possible, which also has its own expansion vessel for the heating circuits. And finally, the pressure maximum, we all already see it, is 6 bar, and this pressure is adjustable according to the heat pump, which is generally around 1 or 2 bars. Here you can see the T-command loop. If you have 2 lines with the same number of PVT, try to make after the T the height of the different hydraulic line the same one to make this T-command loop. If you count, or if you have 2 lines with different number of PVT, you need to implement balancing valves. And finally, there is no landscape connection. You can do landscape installation, but every time with portrait connection. So thank you for your attention. This is the end of this technical webinar. If you have any question, feel free to ask and contact us at this address, support, SUPPORT at Juolson.fr. And thank you. Have a good day. Bye-bye.